on to the calculator section. Now, the wonderful thing about the calculator section for these AP Calculus exams is you don't need a calculator for most of them. This is one of them. Use the graph of y below to answer the question. On what interval is the function only decreasing and concave up? No calculator is needed to stare at this graph and find out what function is only decreasing and concave up means. So decreasing just means it's going down to the right. Concave up means it looks like that. So if you want the combination of these two, little Venn diagram of this is going to be like your side is going to be the one that's concave up and also decreasing, because this is the one that's going down to the right and is also concave up. So between A and B is concave down, not even an option. Between B and C is concave up, but that's not only decreasing. Between B and C starts out decreasing, but then ends up increasing halfway through, so you're not an option. Between C and D is concave up and decreasing, so that's the one that we want. D and E is concave up and increasing. None of the above is not what I want. So this one is C because of what I said just a second ago. So calculator, fun? Yeah, for sure. Let f be a function that is continuous on the closed interval 4, 7, for f of 4 equals 8 and f of 7 equals 18. Which of the following is guaranteed by the intermediate value theorem? Now, this is a calculator section problem that doesn't require a calculator. The intermediate value theorem says that you must, if you're going to go from 4 to 7 and start out at 8 and end up at 18, you must pass through something in between 8 and 18. Okay, if this is continuous, right, you're going to have some type of graph. Now, we don't know what the graph is going to look like. But if this is 4, and this is 7, and this is 8, and this is 18, you start here, you end here. At some point, no matter what it looks like, at some point you're going to hit definitely between 8 and 18. So f of x must be 0. Nope, that's not an option. It doesn't have to be. It could happen, but it doesn't have to be an option. F of x has to be 10. Yep, because at some point we have to go from 8 to 18. Therefore, we have to hit 10 at some point. So yeah, B is going to be my answer. Have to hit 20? Nope, don't have to go beyond 18. The derivative has to be 5, and the derivative has to be positive. For the intermediate value theorem, there's nothing, no rule about derivatives. Like it just doesn't apply. So if you're talking about an intermediate value theorem problem and the options are the derivative is this, the derivative is that, the derivative is not guaranteed at all by the intermediate value theorem. So neither of these even matter. So the answer is B, because again, you have to hit 10 at some point between 8 and 18. The graph of 2e to the sine x minus 3 crosses the x-axis at one point in the interval 0, 1. What is the slope of the graph at this point? All right, so this is a calculator problem. What I need to do is I need to do two things, okay? I need to find out where this guy crosses the x-axis. So let's pretend that that's A. So in my calculator, I'm going to type that in, and I'm going to graph it, and I'm going to find the 0, and in my mind, call it A. It's going to be some crazy decimal. Then what I have to do is I have to find the slope at A. That requires the derivative. So the derivative of 2e to the sine x minus 3 is going to involve chain rule. So f prime of x is going to equal 2 is still 2, e is still e, right? Take the derivative of the inside, which is, we'll keep the inside first off. Let's do that. And multiply everything by the derivative of the inside, which is cosine. So I have cos x. Then minus 3 is minus 3. So what I'm going to do is I'm going to find out where this guy crosses the x-axis. Once I find out where it crosses the x-axis at some point called A, I'm going to take that number and plug it into 2 cos x e to the sine x. Once I get that number, that will get me my slope at that point. So let's go to the calculator and see what happens. All right. So step number 1 is to type out 2e, so the E button is second ln, right, to the sine x which is sine x, close it, move to the right, minus 3. Now we hit graph, and we can see that this crosses the x-axis between 0 and 1 like it says it would. So let's find out what that value is that it crosses the x-axis. So second calc 0. I can just type out the left bounds because I care about 0 and 1. So 0 for the left bound, enter. For the right bound, I'll hit 1 because that's where I care about. And so that my guess is going to be enter. And I end up with 0.4174876. Now I'm going to use a bunch of those points as I do this next part. Now that I'm done that and I have my value, which, make sure you have it written down somewhere because you're going to need it. Okay, that's 0.417 blah, 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 blah. I'm going to do that and plug that into the derivative that I found earlier. The derivative that I found earlier was 2 cos x e to the sine x. So I'm going to plug in that number using as many decimals as I can. 2 cos. Now that number was 0.41749, 0.41749, okay, times, I just like to put the times there because it just separates everything, e to the sine x. So e was there, okay, sine of that same exact number, 0.41749, close it, and we end up with 2.7423, blah, 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 blah. So let's round that off and find out which one of our options seems to match that nicely. All right, so after all of that, we found out that at that point, that A value was 0.41749. More decimals than necessary. When I plugged that in, I ended up with 2.742, which seems to match up with B right here. Okay, so not the prettiest problem for sure, but yeah, that's how you do it. A particle moves along the x-axis. The velocity of the particle at time t is given by v of t, and the acceleration of the particle at time t is given by a of t. Which of the following expressions gives the average velocity of the particle from time t equals 0 to time t equals 6? All right. So what we need is to bring up the average value formula. Now, generally speaking, the average value formula is 1 over b minus a, the integral from a to b of f of x dx. If my job is to find the average velocity of the particle, what we're going to do is use the velocity function. Okay? So that's going to involve us taking 1 over, now here would be my a, here would be my b, 1 over 6 minus 0 times the integral from 0 to 6 of the velocity function, v of t dt. So to simplify that, we get 1 over 6 from 0 to 6, v of t dt, and that gets us the average velocity of the particles. So there you have it. Now I know what you're thinking. You're thinking, well, wait a minute. In order to integrate, don't we integrate a of t? That's a good thought. That's a good thought, but you're finding the average velocity, not the average acceleration. So your heart's there, but that's not what you do in this case. Which of the following is true about f of x based on the graph of y equals f of x below? Well, this is a calculator problem that doesn't require a calculator. All right, so we're just looking at the fact that this graph is of the derivative. Okay, so using this information of the derivative, we should be able to talk about the regular function. Now remember what derivative gives us. Derivative gives us slope. So if the derivative is positive, it's a positive slope, which means it's increasing. If the derivative is negative, that means it's a negative slope, which means it's decreasing. If the derivative is 0, that means it's a maximum or a minimum. And it all depends. So let's look at each of these 3 options and see what those 3 options means in those contexts. Option number 1, okay, is asking what's happening between 0, 1 at 0 to 1 and also 3 to 5. It's saying f of x is increasing. Now, if f of x is increasing, that would imply that the derivative is positive, meaning the slope is a positive number. So if I look at this fact, I care about what happens between 0 and 1. So is the derivative positive between 0 and 1? And here's 0, here's 1. Is it above the x-axis? Yep, check. Also, is the same thing happening between 3 and 5? Is my graph above 3, above the x-axis between 3 and 5? Here's 3, here's 5, check. 1 is true, 1 is true, 1 is true, check. All right, let's look at the second option. F of x has a local minimum. Now, a local minimum occurs when you go from a negative slope to a positive slope. Why? Because if it goes from negative slope, if it's a local minimum, that means you're going down and all of a sudden it hits 0 and then you're going up, so you have a minimum. So am I going from negative to positive at 3? Well, here's 3. I am underneath the x-axis, which means, yep, right here it's negative, at 3, and then it becomes positive. So since my f prime of x, is under the x-axis before 3, and then above after 3, that would imply that I have a local minimum. So this is a true statement, which means 2 is also true. Now 3 is talking about concavity. Okay, so what we're going to do is use a second derivative test, which is kind of difficult to look at, but let me explain. Okay, if we have something that's concave down, that means the second derivative is going to be negative. Now, you can find, if you're like, well, this is the graph of the first derivative. I get it. Okay, but at 5, which is here, what we do is we look at the instantaneous rate of change of the slope. So in other words, the slope of the derivative gives us the second derivative. Since the slope of the derivative is negative, that means the second derivative is less than 0. So this is also a true statement. Okay, so all 3 of these ended up being a true statement, which means the answer is D. So calculator problem, no calculator needed. Fun stuff, happy times. Water is pumped into a tank at a rate of R of t equals 25 times 1 minus e to the negative 0.12 t gallons per minute. Neat. T is the number of minutes since the pump was turned on. If the tank contained 1,000 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 10 minutes? So this is what we're going to do. We're given the rate, all right? The rate's not going to give us the amount of water after 10 minutes, but the integral of the rate is going to give us the amount of water after 10 minutes. So what we're going to do is we're going to run to our calculator and find out what that's going to be. And we're literally going to let our calculator do all the work. Once we find out that number, we add to the fact that we already have 1,000 gallons in the tank waiting for us. Add those numbers up, see what happens. So let's run to our calculator, let their calculator do all the work, and take it from there. Okay, so let's let our calculator do all the work. So we care about doing stuff to the nearest gallon, which is going to make our life easier. First thing that we're going to do is we're going to run to y equals and then type in that integral that we had. 25 times parentheses 1 minus e to the is second ln e to the negative 0.12t. So negative 0.12, and then x is going to be our t. Let's move to the right. Let's close the parentheses, hit graph. Now we care about the integral between 1 and 10. So let's actually do that. We can integrate on here and find, using our lower limits and our upper limits, the actual answer. So second, calc, the integral is 7. So hit 7 or go down. The lower limit, we're just going to type out 0 and hit enter because we're given that exactly. The upper limit is going to be 10, so we're going to type out 10 and hit enter on that. And it's going to give us 104.415, blah, 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 blah. We care about the nearest gallons, so 104 gallons. So what I said on the previous thing is that we're going to take our 104, add it to the fact that we already have 1,000 gallons waiting for us, and I don't really need a calculator for that even though I did it. We end up with 1,104. So let's go back and write that out. All right, so this guy ended up being 104 point something, so 104 after it's rounded, plus 1,000 is 1,104, which is going to be B, baby. Fun stuff. If f prime of x equals ln of 2x minus 1 plus the square root of 3x plus 6 plus 0.3x minus 8, where does f, the original f, have a local minimum? So this is what we're looking for. Okay, this is what we're looking for. F has a local minimum, right, if it looks something like this. Now what that means is you go from a negative slope to a positive slope. What that means, in addition, is if you have f prime, which we do, you have some type of graph that is negative, hits 0, and then becomes positive. So that's what we're going to look for. We are going to graph this guy because that's the derivative. We are going to find not only where it crosses the x-axis, but where it goes from negative to positive on the x-axis. Because if the derivative goes from negative to positive, that means the derivative goes, or the original rather, goes from a negative slope decreasing all of a sudden to a 0 slope here, to increasing, therefore has a local minimum. So let's run to our calculator, type that all in, find our 0, and see which one we get. All right. Y equals, ln is right here. We've got 2x minus 1. Close it. Then we have plus, the square root is second x squared button. Inside we're going to type out 3x plus 6. Get out of the square root. Add 0.3x. Like that, and then minus 8. All right, so what we're looking for is, since this is the derivative and we care about like critical points and stuff like that, we are looking for where this crosses the x-axis, which is going to be right around there. So we need to calculate the 0. So again, and not only that, but we care about it being a negative derivative to a positive derivative. So yeah, this is the point that we care about. So let's do second calc. Let's go to 0 by hitting 2. We're going down. My left bound, obviously I don't see anything here, so I have to make sure that I move right a few times until it starts blinking like that. Okay, hit enter, then cross the x-axis like that. Hit enter again. For guess, always hit enter. And it's going to be 4.675, blah, 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 blah. So let's go back and circle the one that we need. So we got 4.675, which is going to be D. Wasn't that fun? That was fun. The graph below shows the velocity function of a particle in feet per second. Velocity function. Estimate the total distance traveled by the particle in the first 7 seconds. All right, first things first. They don't want where we're at. They want the total distance traveled. And they're asking us to estimate, but since this is a calculator section, we'll actually use our calculator to come up with the most accurate thing that we can. Now, taking the integral of the velocity gets us distance traveled. What the integral gives us is the area under the curve. So this is what I want to figure out. I want to figure out all of these areas. And I know down here is a negative area, but again, what I want is the total distance traveled. So if you think logically, like if I were to take 5 steps forward, 3 steps back, that's 8 steps total. Now 5 steps forward, 3 steps back is a displacement of 2. I don't want displacement. I want to find all of this area, all of that area, and all of that area added together. So let's see what I have. First things first is I have a triangle with a base of 1 and a height of 1. Okay, not only do I have that though, but I have another one right here and another one right here. So what I have so far is 3 triangles with a base of 1 and a height of 1. So the triangles part is going to be 3 times half times base times height. Okay, those are going to be my triangles. I also have, and we're going to go with the easy shapes first, a square with a base of 1 and a height of 1. So my square is just going to be 1 times 1. I think I can handle that without a calculator, but I'm going to use it anyway. But what I do want the calculator for is this third part. I have a quarter of a circle and a half of a circle. So in all, I have I have 3 quarters of a circle. My circle has a radius of 1, so pi r squared, so 3 quarters pi 1 squared. Okay, so this is how I'm going to handle this problem. I'm going to type all of this into my calculator. Okay, even though it is an estimate, and maybe I don't need to, but I'm still going to type it into my calculator to get the most accurate result that I can. All right, so we've got ourselves 3 triangles, so 3 times 1 half times 1 times 1 plus 1 square, so 1 times 1. And then we've got our 3 quarters of a circle, so 0.75 times pi times 1 squared. Even though it seems redundant, we're doing it anyway. And we'll get 4.85, so that rounds up nicely to 5-ish, so we'll go back and make it 5-ish. And since I got somewhere in the 5-ish range, the answer is going to be 5. And that's how you do it. For -1 to 1, let f be a function with the first derivative given by f prime equals e to the 3x to the 4th minus 2x minus 6. Which of the following intervals corresponds to where the graph of f is concave down? Well, we have f, right? And we have f prime. F prime is going to give us some equation. Now, f is going to be concave down when the second derivative is negative. Now, if I give you the graph of the first derivative, okay, and let's just make believe it looks like that. If I were to graph the first derivative, the second derivative, meaning negative, means where my line is decreasing. Wherever the derivative is decreasing is going to tell me where the second derivative is negative. So what I need to do is I need to find the minimum, okay, of where it goes from decreasing, where the derivative goes from decreasing to increasing. Okay, negative slope of the derivative means that the second derivative is negative. So I'm going to run to my calculator, type that guy in, hopefully get a picture that looks something similar to this, and find out my minimum. Once I find my minimum, I can find out where my graph is concave down. So let's do that. All right, so let's graph the derivative. That was e to the stuff. So e to the stuff is second ln. That stuff is 3x to the 4th minus 2x. So 3x to the 4th. Let's scooch out of there. Minus 2x. Get out of there. And then minus 6. And since we care about stuff happening in between -1 and 1, let's just change our window to where the x minimum is -1 and the y minimum is 1. Graph. All right. So what we care about is where this is the derivative. So if we care about concave down, we care about where the second derivative is negative. In other words, if the second derivative is negative, that's implying that the slope is decreasing. So we need negative slopes. So the way to do that is to find the minimum, which is going to be right around there. Once we find the minimum, we can find out when this guy stops decreasing. So let's go to second, calc. Okay, let's do minimum, which is going to be 3. The minimum is right around here, so we can hit enter right away and then just move to the right of it. Yep, I did that. Move to the right of it, and here we have, it starts to increase right there. Hit enter, and our minimum seems to happen at 0.550. So what's going to happen is our graph is going to be, our original graph is going to be concave down all the way up until 0.550. So let's go back and say that. And I ended up with this guy, D, because it goes all the way from -1 to 0.550. So the answer is going to be D. That is when the original function is concave down. The graphs of A of x, B of x, and C of x are shown below. Which equation could represent f prime of x, the derivative of f of x with a local minimum when x is less than 0, or x is less than 0 implies this. If all of these could potentially be derivatives, then what we're looking for is when f of x, if it's a local minimum means that the original graph looks like this, which means its derivative goes from, the slope is negative, so the derivative goes from negative to positive. Okay, in other words, the derivative is going to cross the x-axis starting below it and then going above it. So we need something that looks like this. Okay, since these are all going to represent the derivative, I need something that looks like that. Also, I only care about it happening when x is less than 0, so none of this matters. So it looks like the only graph that does that is this red one, and of course I covered it with my pen. The red one is A. So A is the only one that seems to go through my x-axis on the left side of this axis, and it goes from negative to positive. So we're going to stick with A only. B would represent a local maximum, and C, which is the green one, or wait, no, the green one is B, so the green one doesn't even count. C is a maximum. So yeah, we're only sticking with A. A is going to be our guy, that's it. No calculator needed. If the derivative of f of x is positive for all real numbers x, and the integral between 2 and 9 of f of d dt is 0, which of the following tables of values could represent f of x? All right, so we're looking at two things here. The derivative is positive, which means it's strictly increasing. If the derivative is positive, that means a positive slope throughout. So I need my values to always increase, which means you're decreasing, so you're not an option. B is an option. C is an option because you're increasing. You're decreasing, and you decrease then increase, so those guys are no good. Now what this is saying is between 2 and 9, I have 0. So I don't know what the graph looks like. But if something is going to be 0, that means if you're 2 and you're 9, something like this has to happen where the graph below the x-axis and the graph above the x-axis has areas that cancel each other out, which means I need negative values down here and positive values up here, right? So I need to have negative to positive, and B is the only one that does that. C would give us an area that is only going to be negative because it starts out negative, it ends negative. So C is going to look something like this, where maybe you have this, you have that, right? And it goes like that, which means negative area only. Whereas this has the potential of it is going to cross the x-axis and has the potential of equaling area over area, and then therefore giving you a total area of 0. So that's how you do this problem. Very bizarre, no calculator necessary, you just got to do it. The graph below shows the second derivative, f double prime of x, of the function f of x. On which interval or intervals is the graph of f of x concave up? Well, this is a calculator problem that doesn't need a calculator. If it's concave up, that means the second derivative is going to be positive. And if this is the graph of the second derivative, we care about where the second derivative is positive. In other words, everything above the x-axis, which happens between here and here, and happens from here on forever. All right, so we have a positive second derivative between -1 and 0, and also from 4 on. Now, we're not going to include those numbers because it's 0 at those numbers. So we're going with parentheses here, and that seems to match up with D. So yeah, this is a pretty basic problem, nothing to overthink. You just have to understand what, concavity means when it comes to the second derivative. No calculator needed. A 20-foot ladder is leaning against the wall. The base of a ladder is sliding away from the wall at a rate of 2 feet per second. How fast is the top of the ladder sliding down the wall when the base of the ladder is 12 feet away from the wall? All right, so this is a related rates problem, and this is a calculator problem, but I'm not convinced we're going to need the calculator. Maybe we will, maybe we won't. Let's draw a picture and let's draw what we know. Okay, that is an awful triangle, but leave me alone. This is the wall. I'll call it W. This is the base, I'll call that B, and this would be the ladder leaning up against it. We'll call it L. Okay, what I know is that the ladder is definitely 20 no matter what. I know that this is a right triangle. Okay, what I also know is at the moment the base of the ladder is 12 feet away from the wall. So this is always going to be changing, but at this very moment we have 12. What I don't know then is at the very moment, where is the ladder leaning up against the wall? So what we need to do is we need to find out that W, and we're going to use Pythagorean theorem to do it. 12 squared plus W squared equals 20 squared. 12 squared is 144 plus W squared equals 400. Subtract 144 from both sides. That gets us W squared equals 256. Square root both sides. You don't need to positive or negative anything because this is going to be distance. And the width at that moment is going to be 16. So you're 16. Now, in order to do the related rates problem, we need to realize what is changing and what's not changing. We're going to reuse this equation, but not do too much. The ladder is always going to stay 20. Okay, where my base is and where it changes versus where the wall is and where that changes is always changing. So the related rates problem that I'm going to write out is going to be the base squared plus W squared is going to equal 20 squared. Okay, now what we're going to do is we're going to ddt both sides. Take the derivative with respect to time. So ddt, ddt. That leaves us with the derivative of b squared, which is 2b, with respect to t is db dt, plus the derivative of w squared is going to be 2w dw dt. That's going to equal 0 because the derivative of a number is 0. Okay? So let's plug in what I know and what I don't know. I now know that b is 12, so 2 times 12. db dt is the top of the ladder sliding on the wall, the base of the ladder is 12 because the base of the ladder is, no it's not, it's, what is it? It's sliding away from the wall at 2 feet per second. So db dt is 2 because it's 2 feet per second. Okay, that's going to be plus 2 times w, which is 16. dw dt is what I'm trying to find. That's going to equal 0. So let's write this all up here. 2 times 12 times 2 is 4 times 12, which is 48. Plus 2 times 16 is 32. dw dt equals 0. Let's subtract 48. Let's subtract 48. 32 dw dt is going to be negative 48. Divide both sides by 32. Divide both sides by 32 is dw dt equals negative 1.5. Why negative? Because it's sliding downward. So negative 1.5 is going to match up with 1.5. And that's how you do that problem. No calculator needed. You could have used a calculator, I guess, but not needed. A particle moves along a line so that its acceleration for any positive time t is given by a of t equals, holy crap, ln of 2.1 t plus 1.2 plus 1.43 times the square root of 0.021 t minus 0.18. If the particle's velocity at time t equals 0 is 4, what is the velocity of the particle at time t equals 8? All right, so we're given an acceleration function. We're talking about velocity. So in order to turn acceleration into velocity, we need to integrate the acceleration. Okay, we're going to do that from 0 to 8. This will give us the total velocity from 0 to 8. On top of that, we're going to add 4 because the velocity is already 4. So what I need to do is I need to run to my calculator, type that guy in, find the integral from 0 to 8, and add 4 to it. All right, so let's go to that y equals and start typing stuff in. ln of 2.1, t is x, okay, x is t, plus 1.2, close the parentheses, plus 1.43 times the square root of 0.021 t, which is x, let's get out of there, minus 0.18. All right, let's hit graph. Not so bad. But what I have to do is I have to integrate from 0 to 8. So let's second calc. 7 is my integral. Lower limit is 0. Upper limit is 8. So you hit your number, you hit 8. This guy gives me 10, I'm sorry, not 10, but 18.356. So if we were to take that guy, 18.356, and add 4 to it, we'd get 22.356. So let's go back and make that happen. And so we ended up with 18.356-ish plus 4 is 22.356-ish, which looks to be C. Gross. Which of the following must be true? All right, so let's do this. Okay, let's kind of treat this as if it's u substitution. Let's let u equal 3x. So du dx is going to be 3, and after flip-flopping the 3 and the dx, we get du over 3 equals dx. So now that guy can be written as the integral from 5 to 10 of f of u, oh, be careful, du over 3. So let's rip out the 1/3. 1/3 from 5 to 10, f of u du. Okay. Now, what happens is basically we're going to take the derivative of some f of u, and that's going to give us this right here. We have the integral from 5 to 10 of f of t. Okay, and remember, since this equals 15, right, I can multiply everything by 3, multiply both sides by 3, and that's going to get us 45. The limits don't change. They're still 5 and 10. And yeah, so kind of a very, very, very bizarre problem. Where am I? F of t dt equals 45. Oh, between 5 and 10. Yeah, kind of a very strange problem. Not a huge fan of it, but yeah, that's how you would do it in this case. Let f be a polynomial function with values of f prime of x as selected values of x given in the table below. Which of the following must be true for -3 to 6 for our x values? So we have -3 to 6. We have a bunch of coordinates given to us. All right, now this is f prime of x. Okay, and we want to talk about facts of f prime of x. So what we know is the derivative gives us slope. All right, negative derivative is going to be decreasing function. Positive derivative is going to be an increasing function. So let's kind of go through all of this stuff and see what we have here. All right, now the first one asks if the graph of f is concave up. Now, if you might remember from AP Pre-Calculus, concavity has to do with the increase or decrease of its rate of change. I'm going from 4 to 0 to 2 to 6 to 3. Something is going to be concave up if the rate of change is increasing, and my rate of change is not increasing. In fact, I start out by decreasing. So since my rate of change is not increasing, this guy is not concave up. The graph of f has at least 2 points of inflection. All right. Well, looking at what I have, it looks like f prime changes direction twice. Right? Because I go from 4 to 0 to 2, so that's a change of direction. And then from 2 to 6 to 3, there's another change of direction. So since it changes direction twice, we can assume that the graph has 2 points of inflection. Now let's rule out the others. F is always increasing. That's false because f prime of 1 is 0, which means if it's always increasing, if f prime of 1 is 0, this means we have a 0 slope right there, which means not always increasing, so C won't work. F has no critical points. Well, that's not true because there's one right there. And so you're not right. F has at least 2 relative extrema. No, because it's always increasing except for at one spot. So we can't determine if there's more than one relative extrema. So B's got to be it. So this is a calculator section that didn't require a calculator. It just kind of required a little bit of knowledge about the derivative and how we can use that derivative to our advantage. The region R is bounded by the equations y equals log of x plus 1 plus 2 and y equals x squared in the first quadrant. I don't know where the rest of the word quadrant is, but it's gone. What is the volume of the solid form when the region R is rotated around the x-axis? So, all right, logs usually look like this, right? X squared usually looks like this. So you're going to be my A, you're going to be my B. I'm rotating you around the x-axis. Right? So this is the washer's method. So what we're going to do is, since my log is the one that's probably up here, you're going to be my log and you're going to be my x squared. So the equation or the integral that I'm going to set up, okay, is going to have pi living out front. I need to find my lower limit. I need to find my upper limit. And then what I'm going to do is I'm going to take log of x plus 1 plus 2, square that, and then I'm going to subtract out x squared squared. Okay, dx. So again, I'm going to graph these guys. I'm going to find out where they intersect. Once I find out where they intersect, I'm going to write those numbers down, and then I'm going to use this guy right here, the integral, and I'm going to plug all of that stuff in. I'm going to have to make sure that I include pi on the inside when I do the integral so I don't make a mistake. But I'm going to integrate that using my calculator, see what number I get, and we'll find out what happens. So let's start graphing away. We've got log of x plus 1 plus 2. So there's my x, there's my plus 1, close it, plus 2. And then my other guy was x squared. Now I need to find out where these guys intersect in the first quadrant. Now this is good news. Let's zoom in. This is good news because these guys intersect over here, which means my left limit is going to be 0. So my left limit is going to be 0 based on the fact that my first point of intersection is over here in a different quadrant. So I'm going to use 0 as my lower limit. And so all I have to do is find out my upper limit. So hit second calc. Let's find out where these two guys intersect. So let's move over here a little bit. Hit enter. Let's move over here a little bit. Hit enter again, and I get 1.5513. All right, so let's set up our integral. Let's go back here. I don't need this anymore. Clear, clear. Now, I'm going to throw pi in front of everything. Pi. Okay. And then I have parentheses, log of x plus 1, close it, plus 2, close it, square it, and then minus x squared, close it, square it, and then close it one more time. All right, so now that I have what I need, I think everything is typed out correctly. I don't think I have any errors. I can hit graph. All right, that looks pretty good to me. Let's hit second calc and hit 7. Type in my lower limit, which was 0, my upper limit, which was 1.551. Hit enter, and I get 18.757 bloody 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 blah. Whew. So let's go back and type that out. All right, so we ended up with 18.757, which is B. And that's going to do it for the calculator section. So on to some open-endeds. Fun, fun, fun.